So this is a video in support of our final project for the subject. So this is the up down counter with 7 segment display. So the main parts of this project is actually the Astable multivibrator, which is the 555 timer IC. This one, the up down counter with BCD outputs, and of course the BCD to 7 segment decoder, which drives our 7 segment display. So this one also converts our BCD format to the decimal format. Okay, so you might have noticed that I am using solid wires in connecting my power lines supply, and instead of all connectors with header pins, because if I do that, the breadboard or the wiring of the breadboard gets easily overcrowded. So in connecting this project, I suggest that you connect first the power supply lines, the positive and the ground of all the ICs first, and then before you connect the input and outputs of the ICs. That is to avoid getting messed up with the wires, the power supply lines and the IO lines. So this is the schematic diagram of our stable multivibrator circuit. So using the 555 timer, this one. So we actually need only about 4 components aside from the IC, of course, to make it work. So this is just the power supply and the monitoring circuit, which is composed of the LED and the bias resistor. This is just to monitor the output signal. So number 1 is of the IC is the ground, connected to ground. Number 8 is the supply, positive supply. And number 4 is actually our reset, also connected to the power supply line. So, and then you have 2 resistors. I'm actually using a variable resistor here, which controls the discharge of our capacitor here. So this is connected to the discharge pin, and the threshold pin is connected to the positive side of our capacitor, which is 10 microfarad. Number 2 is the trigger, also connected to the threshold pin. So I'm using here a 9 volts power supply, although you can still use 5 to 15 volts for the 555 timer. Okay, so I can actually adjust. Yeah, let me play it first, the simulation. I can actually adjust the speed of the clock by using the variable resistor here. Okay, so you can make it slower and you can make it faster. So this is the actual circuit now, this one. So this is the capacitor, the 10 microfarad. This one is the 470 ohms, and the potentiometer, of course, the variable resistor. This one is 103, coded 103, which is 0.01 microfarad, connected to the control pin to ground. No, so this one is just the bias of our LED. So this one is the number 3, which is the output of the clock, connected to the clock input of our up down counter. This is the schematic diagram of our up-down counter with display. So this is the 74LS192, which is the up-down counter, BCD counter. So the output is in BCD format, and then this one is the clock pulse. You can actually make it a countdown or a count up counter by interchanging these parts 4 and 5. So the output of our BCD counter is actually connected to the input of our BCD to 7-segment decoder. So there are 4 inputs, and the output also of our BCD decoder goes to the inputs of the 7-segment display. So these are the pins of your BCD decoder and the segments of the 7-segment display. So in this case, do not mind the numbering of the input of the 7-segment display, because I'm actually using a different type of 7-segment. This one. Where's that? So the numbering here is actually different. So this is actually the pin configuration of our 7-segment display. So this one is the common cathode and this one is the common anode. So we are actually using the common anode of the 7-segment in this project that we are now doing. So take note of the pin configuration. So this is actually numbered as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So G is 10, E is 1. Okay. So this is now the actual connections on our breadboard. So I can actually make this slower if I like, counting up, or faster or slower. Okay. And then faster. Again, please note that we are still using the external power supply of our IDTB for all our ICs here on the breadboard. So never use a power supply or unregulated power supply, no, especially if it's before the 708 regulator. So, and also notice that we are also using the output LEDs of our IDTB to monitor the BCD output of our BCD counter. However, I actually increased the bias resistor for the output LEDs by inserting in 1 kilo ohm resistor. This is to lessen the current drain of the LEDs, preventing the BCD counter from getting drained also. Because if I put the output LEDs directly to the BCD counter, no, most likely the BCD will get drained, no, and then it will start skipping counting as experienced. So never forget to add additional 1 kilo ohm for the bias of the output LEDs. Okay, so this is it.